Welcome you all in this video. In this video, we are going to discuss the example on eigenvalues and eigenvectors of symmetric matrix. Here the eigenvalues are non-repeated. So this is example of symmetric matrix. You see the diagonal numbers here 3, 5, 3, and the opposite of this is -1 here, -1 here, +1, +1, -1, -1, which are equal numbers. That means this is symmetric matrix. So uh, let this is a matrix. So general characteristic equation for symmetry matrix is this. So we want to find here the characteristic equation for this. So we know the general characteristic equation. The lambda cube minus s1 lambda square plus 2 s2 lambda minus determinant equal to 0. Now find here the s1 s2 determinant of this matrix. Which is here s1. S1 is sum of these diagonal numbers. So add this 3, 5 and 3 here. So 3 plus 5 plus 3. So add here. So 3 plus 3 is here 6, 6 plus 5 is 11. Now S2. S2 is sum of minor of these diagonal numbers. So these three present in first row and first column. So remaining elements here 5 minus 1 minus 1 3. So write this element in determinant as 5 minus 1 minus 1 plus 3. Then here plus another diagonal numbers here 5. This present in second row and second column. So delete this row and column. So remaining numbers here this corner numbers 3 1 1 3. So write here 3 1 1 3 plus now last these numbers. So this number present in last to last column. So delete all numbers. So write these four numbers in determinant. So 3 minus 1 minus 1 5. So 3 minus 1 minus 1 5. So keep in mind here. So a minor of these diagonal numbers is we can write the determinant as so this first determinant for this, second determinant for this last corner numbers, and third determinant for this first four numbers. So now simplify this for solve the determinant. First multiply two numbers 5 into 3 is 15 minus then multiply these two numbers -1 into -1 is plus 1 this plus then multiply these two numbers 3 into 3 is here 9 then right here -2 multiply these two numbers 1 into 1 is 1 then plus multiply these two numbers 3 into 5 is 15 right here -2 multiply these two numbers here -1 -1 both are negative so -1 is plus 1 so that is plus 1 so now do the calculation 15 plus 15 is here 30 then -1 -1 -1 -3 then plus 9 here so equal to 30 then -3 plus 9 is here -6 so we get here 36. Now find the determinant of a. To find the determinant of a, so use these first row numbers. So this 3 right here 3 another number here -1 another number here plus 1. Now take the term as positive then negative, so negative into here positive here positive. Now write the minor of this 3. So this 3 present in first row first column, so these remaining numbers so write in determinant as 5 -1 -1 plus 3. Now the minor of this -1. So this -1 present in second column and first row. So remaining -1 -1 plus 1 3. So here -1 -1 plus 1 and 3. Now last number here this 1. So this present in first row and last column. So remaining numbers here -1 plus 5 1 and -1. So here -1 plus 5 1 and -1. Now solve this determinant. So this 3 in bracket multiply these two numbers 5 into 3 is 15. Right here -2 multiply these two numbers -1 into -1 is plus 1. Then plus we multiply 1 to any number or any expression we get a number for expression. So Don't write this one here. So minus 1 into plus 3. So multiply these two numbers first. Minus 1 into 3 is here minus 3. So right here minus 2 multiply these two numbers. So plus 1 minus 1. So plus 1 minus 1 is here minus 1. But here already minus, so minus minus plus 1. Now this plus here also 1. So minus 1 into minus 1 is here plus 1. So right here minus 2 multiply these two numbers. 5 ones are 5. So now 3. So 15 minus 1 is 14. Now we can directly calculate here. 15 minus 1 is 14. 14 into 3 is here 42. Now minus 3 plus 1 is here minus 2. 1 minus 5 is minus 4. Now add this number. So minus 2 minus 4 is minus 6 and 42 minus 6 here 36. So put this determinant A, S2 and S1 here. So we get lambda cube minus S1 is 11 lambda square. Then S2 is 36, so plus 36 lambda and minus determinant is 36, so minus 36 equal to 0 is characteristic equation. Characteristic equation of the given matrix is A. Now find the eigenvalues of this matrix A. Means we want to find here the values of lambda of this equation. We find the root of this equation. So this is cubic equation. Degree of this equation is 3. So it will be 3 roots or 3 values of lambda. So how to find the first? Find the first root. So put here lambda equal to 2. If lambda equal to 2 satisfy the equation, so that is lambda equal to the first root of this equation. So check. So put lambda equal to 2 here. So 2 cube is here 8. Then 2 square is 4. 4 into minus 11 is minus 44. Then 2 into 36. So put lambda equal to 2 into 36 is 72. Then here minus 36. Now add this. So 8 plus 72 is here 80. And minus 44 minus 36 minus 80. So we get here 0. So that means lambda equal to 2 is first root of the cubic equation. Now to find the other two roots, so use your centric division to convert cubic equation into quadratic equation. So by centric division, so draw here one vertical line, draw one horizontal line. So put here this first root lambda equal to 2 and write here the coefficient of this cubic equation. Lambda cube coefficient is here 1. Put here 1. Then lambda square coefficient is minus 11. Right here minus 11. Then lambda coefficient is 36. So right here 36. Then last constant minus 36. 16 minus 36. What is the calculation? This first number as it is here. So 1 into 1 into 2, multiply these two numbers. 1 into 2 is here 2. Then add these two numbers. Minus 11 plus 2 is here minus 9. Then multiply these two numbers. So 9 into 2 is here minus 18. And add these two numbers. 36 minus 18 is here plus 18. Now multiply these two numbers. 2 into 18 is here 36. So right here 36. So minus 36 plus 36 here 0. So we get here 0. So always here we get 0. Now form the quadratic equation. How to form? So multiply lambda square 1 into lambda square. Then multiply lambda. So minus 9 lambda and this constant as it is. So 18 equal to 0. Now find the root of this quadratic equation. How to find? By using factorization method. So lambda square coefficient is 1, 18. So multiplication of both here 18. The factor of this 3 into 6. 6 into 3 is here 18. But addition of both here 3 plus 6 is here 9. But we want here negative 9. So multiply here minus, here also minus. So multiplication of this minus 3 into minus 6 here plus 18. And addition of the both number here minus 3 minus 6 here minus 9. So we get here minus 9. So we can write the factor of this expression as lambda is minus 3 in second bracket. So lambda minus 6. Lambda minus 6 equal to 0. Now separate this. Lambda minus 3 equal to 0 and lambda minus 6 equal to 0. Now transfer this minus 3 to this side, this minus 6 to this side. So we get here lambda value is plus 3 and minus 6 goes to positive 6. So we get positive 6. So therefore we get here three values of lambda. Lambda equal to this 2, this 3 and this 6 are eigenvalues of the matrix A. Now find the eigenvector corresponding to the eigenvalue. So here these three eigenvalues are different. So we will get here the three different eigenvectors. So to find the eigenvectors, so we need here the homogeneous form of equation. So how to find the homogeneous form of equation? So homogeneous form of equation in matrix form. Okay. So this is matrix. So subtract here by lambda. 3 minus lambda, 5 minus lambda, and 3 minus lambda. So this is characteristic matrix. So write here characteristic matrix as 3 minus lambda, 5 minus lambda, and here 2 minus lambda. And all other numbers minus 1 plus 1 minus 1. So minus 1 plus 1 minus 1. This is symmetric matrix. So this number here as it is, and this number 1 as it is here, and this number as it is. Characteristic matrix. So multiply one vector, that is column matrix. So in that column matrix, the unknown variable present x, y, z equal to, so this is zero matrix. So this is homogeneous form of equation in matrix form. Now find first eigenvector corresponding to lambda equal to 2. This first number. So replace this lambda by this 2. So we get here 3 minus 2 minus 1, 1 minus 1, 5 minus 2 minus 1. This 1 as it is, minus 1 as it is, 3 minus 2. Now here x, y, z equal to 0, 0 and 0. Now simplify this. 3 minus 2 is here 1, this minus 1, this plus 1, here minus 1, 5 minus 2 is here 3, here minus 1, then here 1, then here minus 1, 3 minus 2 is here 1. So here x, y, z equal to 0, 0 and 0. Now form the equation. But see, the first row and last row numbers here same. So after applying a row transformation, so we get a 0, 0, 0. So we will find here only two equations. So see from first and from second. So write the equation for this. So this x coefficient, y coefficient, and z coefficient. X coefficient is 1. So it's here minus y, then plus z equal to 0. Then here minus x plus 3y, and this minus z equal to 0. Now use your Cramer tools to find the value of x, y, z. So for x, write the coefficient of your y and z in denominator in determinant form. So here y coefficient is minus 1 plus 3, minus 1 plus 3, z coefficient is 1 and minus 1. 1 and minus 1. So equal to, so minus y divided by second term, negative here. So write the coefficient in determinant of the x and z. X coefficient is 1 and minus 1, 1 and here minus 1. Z coefficient is 1 and minus 1, 1 and here minus 1. Now equal to z divided by. So here for we need here we want to find a z value. So take the coefficient of x and y. X coefficient is 1 and minus 1. 1 minus 1. Y coefficient is minus 1 plus 3. Minus 1 plus 3. That's all the determinant. So x by, so first multiply these two numbers. Minus 1 into minus 1 is here plus 1. So right here minus 2 multiply these numbers. 3 ones are 3 here. Then equal to minus y divided by. Then multiply these two numbers. 1 into minus 1 is minus 1. So right here minus 2 multiply this number. Minus 1 into plus 1 is here minus 1. Then equal to j divided by, multiply these two numbers. 1 into 3 is 3. So right here minus, so multiply these two numbers. Minus 1 into minus 1 is here plus 1. So x divided by 1 minus 3 is minus 2 equal to minus y divided by minus 1. So minus minus here plus 1. So we get here 0. So j divided by 3 minus 1 is 2. So we get here x by here minus 2 equal to, so see, so minus y divided by minus 1 plus 1 is here 0. So equal to j divided by 2 here. Now divide throughout the equation by this 2 for this denominator. So we get here x by minus 2 by 2 is here minus 1. Or here we can get here 0. So negative we get 0. And then here j by 2 by 2 is here 1. So multiply by 2. So 2 by 2 cancel, 2 by 0 here. So 2 by 2 is here 1. So we get here. So now let here x by minus 1, x by minus 1 equal to y by 0 and z by 1 equal to k. So implies here the value of x. So x equal to minus 1 into k is here minus k, and y equal to 0 into k is here 0, and z equal to 1 into k is here 1k. Write the vectors. So x1. So write the vector as another side. So here x1 vector, x1 vector, x1 vector. So x1 vector here minus k, x value, y value is 0, z value is k. Now take the common k here. So we get here minus 1, 0, 1. So is eigen vector of the matrix A corresponding to lambda equal to 2. Now second vector, eigenvector corresponding to lambda equal to 3. This second eigenvalue. To find the eigenvector corresponding to this, so replace lambda here by 3. So we get 3 minus 3, 5 minus 3, 3 minus 3. 3 minus 3, 5 minus 3, and we have 3 minus 3. And all other numbers as it is minus 1 plus 1 minus 1. Minus 1 plus 1 and minus 1. So the symmetric matrix. So right here is minus, this plus 1, and this here minus 1. And here unknown matrix x, y, z. That is vector here. And here 0, 0 and 0. Now here to see in matrix 3 minus 3 is here 0, 3 minus 3 is here 0, and minus 1 here, plus 1 here, then minus 1, 5 minus 3 is here 2, then here minus 1, 1, minus 1, 3 minus 3 is here 0, then here x, y, z equal to here 0, 0, and 0. Now write the equations. So this is x coefficient, y coefficient, z coefficient. 0x minus y plus z equal to 0, minus x plus 2y plus 2y minus z equal to 0. Then here x minus y, then plus 0 z equal to 0. So use these two equations to find the values of x, y, z. See here for x, so x divided by coefficient of y and z. Y coefficient is a minus 1 plus 2, right here minus 1 plus 2. Z coefficient is a 1 minus 1, 1 minus 1 equal to negative y divided by, at the coefficient of x and z, 0 minus 1, 0 minus 1, z coefficient is 1 minus 1, 1 minus 1 equal to 0 divided by the coefficient of x and y, x 0 minus 1, 0 minus 1, coefficient of y minus 1, 2, minus 1, and here 2. Now x by, so solve this determinant. So minus 1 into minus 1 is here plus 1, right here minus 1 multiply this to 2 ones are 2 equal to minus y divided by, multiply these two numbers, 0 into minus 1 is here minus 1, so right here minus 1 multiply these two numbers, minus 1 into minus 1 is here, minus 1 into plus 1 is here minus 1, so equal to z divided by, multiply these two numbers, 0 into 2 is here 0, so right here minus 2 multiply these two numbers, minus 1 into minus 1 is here plus 1, so x divided by 1 minus 2 is minus 1 equal to this minus y divided by minus minus plus 1 minus 1 here 0 equal to j divided by here minus 1. So now we sorry for here. So this with this mistakes here. So 0 into minus 1 here 0, and this minus 1 plus 1 right here minus minus plus 1. So we get here plus 1. So now multiply here negative. We get here x by plus 1, y by 1, and z by 1 here. So let here x by 1, y by 1, and z by 1 equal to k. So equate this x by with k, x, y with k, z with k. So this implies that x equal to 1 into k, y equal to 1 into k, and z equal to 1 into k. So write this in the vector as, so x2, second vector, x2 equal to, so write x value here k, y value k, z value here k. So k, k, k. Take the common k here. So we get here 1, 1, 1. So is eigen vector of A corresponding to lambda equal to 3. Now third vector, eigenvector corresponding to Lambda equal to last eigenvalue is 6. Third eigenvalue is 6 is 6. Now replace this lambda by 6. So 3 minus 6, 5 minus 6, 3 minus 6. Then minus 1 plus 1 minus 1. Here 3 minus 6, second diagonal element, 5 minus 6, third diagonal 5, 3 minus 6. And all other numbers here is minus 1 plus 1 minus 1. Minus 1 plus 1 minus 1. So minus 1 here, then plus 1 here, and this minus 1 here. So symmetric matrix. So this is characteristic matrix. Now multiply here. X, Y, Z unknown vector. We want to find this unknown vector. And this is 0, 0, 0, 0. Now simplify this. 3 minus 6 minus 3 minus 1 plus 1 minus 1. 5 minus 6 is here minus 1. Here minus 1. This 1 minus 1. 3 minus 6 here minus 3. Now form the equation here. X, Y, Z equal to 0, 0, and 0 here. Now form the equation. So this x coefficient, y coefficient, z coefficient. From first row, minus 3x minus y plus 1 equal plus 1z equal to 0. Second equation, minus x minus y minus z equal to 0. Third equation, x minus y minus 3z equal to 0. So use these two equations to find the value of x, y, z. So right here for x, coefficient of y, and z, y coefficient minus 1 minus 1. Right here minus 1 minus 1. So it is plus 1 minus 1 plus 1 minus 1 equal to minus y here. Here divide. So x coefficient and z coefficient, minus 3 minus 1 minus 3 minus 1. Then z coefficient 1 and minus 1. 1 and minus 1 here. Then equal to here divided by the coefficient of x and y. X coefficient minus 3 minus 1 minus 3 minus 1. Then y minus 1 minus 1 minus 1 minus 1. Then x divided by, multiply this, minus 1 into minus 1 is plus 1. So right here minus to multiply this two number, minus 1 into plus 1 is here minus 1 equal to is here minus y divided by minus 3 into minus 1 is plus 3. So right here minus 1 into plus 1 is here minus 1 equal to a divided by minus 3 into minus 1 is plus 3. So right here minus to multiply these two numbers. Minus 1 into plus 1 is here. Minus 1 into minus 1 is here plus 1. So now simplify this. X by minus 1 plus 1 plus 1 plus 1 is here plus 2 equal to minus y divided by this plus 1 and this is plus 4. Then equal to here z by 3 minus 1 is here 2. Now divide out the equation by 2 for this number. So x by 2 is here 1. This minus come here. Y by 4 by 2 is 2. So this minus and z by here 1. Now let x by 1 equal to y by minus 2 equal to z by 1 equal to k. So here this implies that when x equal to 1, y equal to minus 2 into k, minus 2 k, here 1 into k, multiply this 1 with k, minus 2 to this k, and 1 to k. So we get here x y z. So z equal to 1 into k. Here k. So last vector x3 equal to here x, y, z. Unknown variable here. So we are finding it here x, y, z value. To put here x value, k, y value here, minus 2 k and z value here. Okay, now take the k common here, so we get here k in a bracket 1 minus 3 1 is eigen vector of A corresponding to lambda equal to 6. So we got here three vectors corresponding to three different eigen values. Thank you.